Hi, my name is Dylan Barnes, and for my physics project, I would like to give a little lecture on projectile motion. A projectile is an object moving in two directions under the influence of Earth's gravity. Its path is a parabola. You have to analyze the horizontal and vertical motions separately. The speed in the x direction is constant, and the object in the y direction moves with constant acceleration. If an angle is launched at an initial angle of 0 degrees with a horizontal, the analysis is similar except that the initial velocity has a vertical component. Projectile motion is motion with constant acceleration in two dimensions, where the acceleration is g and is going down. Projectile motion is parabolic. Taking the equations x and y as a function of time and combining them to eliminate t, we will then be able to find y as a function of x. And to give an example of projectile motion, I would like to solve an example problem. A projectile is fired with an initial speed of 47.6 meters per second at an angle of 42.2 degrees above the horizontal on a long flat firing range. So first we're going to determine the max height reached by the projectile. And to do this, we know that the initial speed is 47.6 and the angle of inclination is 42.2 degrees. So the equation we shall use times angle squared over 2g, which gets us 47.6 times sine 42.2 degrees squared over 2 times 8. And so by using this equation, we have determined that our max height, the max height reached by the projectile is 52.2 meters. We now need to determine the total time that the projectile is in the air. To use this equation, I'm going to do 2 times the initial speed times sine of the angle over g, and with that, so 2 times 47.6 sine 42.2 over 9.8. And by using this equation, we can determine that the total time the projectile is in the air is 6.53 seconds. Let me box these answers. For this next part, we're going to determine the total horizontal distance covered, or the range. To find this, we're going to do g over g, and that is the initial speed over g times sine 2 of the initial angle. And so that would be 47.6 squared over 9.8, sine 2 times 42.2 degrees. And that means, and by using this equation, we have determined that the total horizontal distance covered or the range is 230 meters. Next, we need to determine the speed of the projectile 1.3 seconds after firing. By doing this, the equation we're going to use for this, first we have to find our x and our y. Using this equation, so 47, so our initial angle, our initial speed times the cosine of our initial angle gets us our x, which is 35.26 meters per second. And then to find the y, we get sine minus gt, which equals, so 47, our initial speed times sine of our initial angle, which is 42.2 degrees, minus the g times the time given to us, which is 1.3 seconds, 3, so making our y 19.23. And by taking our x and our y, we're going to plug it in to this equation. The x squared plus the y squared equals 35.26 squared plus 19.23 squared. And that's going to get us, so the speed of the projectile 1.3 seconds after firing is 40.2 meters per second. And then last, we're going to determine the direction of the motion of the projectile 1.3 seconds after firing. For this, we just need to plug in the numbers given to us up here, our x and y up here, into this equation. We're going to put our y over our x. 6. And the direction of motion of the projectile 1.3 seconds after firing is 28.6 degrees. This has been my lecture on projectile motion. Thank you.